What is physics, Steve? Well, what is physics according to you? What did you study? What did you graduate in?
Well, as you say, I did astronomy, but that's a branch of physics in many ways. So, my view of physics, well, to me, physics is an inquiry into the nature of the physical universe around us, as opposed to biological sciences and maybe chemical sciences, where we make some distinction.
You may want to speak up.
Okay. But fundamentally, physics is an experimental science, so that we take measurements, we make observations, we log our data, and then we try to look for patterns and things in this data and observations to come up with some kind of idea to give a tangible explanation to these phenomena. And so this gives us a basis in reality from experience. Now, physics is divided into a number of areas, somewhat arbitrarily, but not entirely so, I suppose. But we have experimental physicists who do the experiments and conduct the observations, such as astronomers and others. And then we have theoretical physicists. Now, I would make a distinction between two types of theoretical physicists. There's the theoretical physicist like Faraday, who was also an experimentalist as well. He conducted experiments and logged his data and all. Then he came up with some, what we might call a tangible or physical explanation for the observations that he made around him and in the laboratory. But he didn't use mathematics. He wasn't trained in mathematics. He didn't think in terms of mathematics. So the distinction is his ideas or theory were non-mathematical ideas. Well, that's a kind of theoretical physicist. Then we have another type of theoretical physicist, for some reason now, which has dominated the whole field of physics for a long time, and this is the mathematical physicist who plays around with mathematical equations and really doesn't do anything with experiments. Maybe once in a while might look at some data just to see what's there now and then, but it's not crucial. And because they go off and wander into a land of pure ideas based on mathematical reasoning. So there we've got three types really: the experimentalist and observation person or people. Then we have maybe a mix of the theoretician with the experimentalist. It's hard to make a distinction, such as Faraday and others who come up with some tangible ideas. Then we have the mathematical guys who come along and play around with equations. So the only trouble is, with this sort of approach to physics, the physical foundations of physics are lost. There's no real concentration now on what's happening around us, but only what's happening in our brains, or their brains, and their pencil and paper with their symbols. The true approach is you take a data set and you try to model this data set. You make a model and you try to fit your model to the data set. Unfortunately, nowadays, and actually for quite a long time, it's been the other way around, because the theoreticians, particularly the mathematical physicists, have held the reins for way too long, and so now data sets are being made to fit their models. This is not the way to do physics, in my view. To me, physics is a rational analysis of the physical environment based on experiment, come up with some physical ideas or tangible ideas to describe or to account for this phenomena, and then we can use mathematics judiciously to build ourselves a model, but never lose sight of the fact that all of this mathematics is just a handy tool. As Heaviside once said, it was told as a good joke upon an old mathematician that the poor man went mad and mistook his symbols for reality, such as M for the moon and S for the sun. Well, I think that puts it pretty well in a nutshell as to what we have currently, Bill.
Is math the language of physics?
I don't think so.
What is the language of physics?
The language of physics, that's a good question. Well, the language of physics, what would I say? I think it's the formulation of, for want of a better word, some tangible ideas as to how one object interacts with some other object, for instance.
Yeah. I think we've strayed quite a bit from what physics is supposed to be. The way I look at it, science is a body of explanation, rational explanations. If it's not rational, if the explanation is not rational, it belongs to religion. Very simple. So we have rational explanations, irrational explanations. These belong to religion, these belong to science. Science is divided into two parts. Physics on the one side, philosophy on the other. Physics deals with objects and causes, and philosophy deals with concepts and reasons. History is an example of philosophy. You can talk about why Napoleon went to Waterloo to fight. That's still a scientific pursuit. You're just trying to figure out why he did it, and you're going to try to explain that. If you give a rational explanation, well, you have an explanation. But that's something different than what physics does. Physics tries to determine causes, especially of the invisible world that Mother Nature runs. In order to comprehend it in our terms, in order to say that it is rational, you must have an object. Physics must have an object. You cannot do physics without objects. We were talking about the field yesterday and this morning, a matterless field. You know, what are we talking about? What is this ocean without fish? We need some physical object in order to do physics. And the funny thing is that in the last 10,000 years, no one has defined the word object in a way that we can use it consistently in a scientific manner. Here we have objects, things. They are the basis, the foundation of physics, and we haven't defined what an object is. You can go through any textbook of physics, you will not find it beginning with, this is an object. You will not find this. And that's really funny because, if you do define this word, a lot of mathematical physics gets thrown by the wayside. The way I define an object is that which has mass. That which has shape. If it has shape, it's an object. If it doesn't have shape, automatically a concept. You go through the dictionary, you can take every single word in there and put them under one list or the other. It's black and white. If it's a table, object. If it's, justice, concept. It's very simple. And so when we do this, we get rid of half of the words used, at least half, maybe 100% of them, of the words used in mathematical physics today. What is energy? Can we make a picture of energy? Can I draw energy? Does energy have shape? Well, the answer is clearly that it's not. And just by going to the dictionary or the Wikipedia or any source that you choose of your choice, you will find that energy is defined as a concept. It is defined as a concept. In fact, it begins the capacity to blah, 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 blah. It continues. The capacity. Capacity is a concept. There's no physical object called capacity. So energy is a concept. But here, the mathematical community transfers energy. And you say, well, how do you transfer a concept? How do you transfer love? How do you transfer information? How do you transfer justice? How do you do this? The language is wrong. The language is wrong because we are using concepts as objects. We have reified all these words, and the entire vocabulary, the entire language of mathematical physics today is based on concepts. We have gone from people who work with experiments, hands-on, touching things, to people who do armchair physics like Hawking and Witten. And what do? All they do is just throw variables around. They never touch the physical object in their life. Are they doing physics? Well, the answer is clearly no. Unless they can put an object out there on the screen, unless they can show me a movie of their theory, of their explanation, that I can see objectively without their explanation, should be able to see the movie and see how, you know, how this explanation works just by looking at the movie. But then he's got to put something in the film. I've got to see objects. I've got to see shapes. What's he going to put for the movie known as transfer of energy? What is he going to put on the screen? What am I going to be watching? What am I going to be watching for the movie called Carrying a Force? What is the particle carrying? Whoa, I don't see anything on this spec. What are we going to see for moving a mass? You know, we can go on and on. It's all concepts, and we have shorthanded all these things. We say, oh, we know what we're talking about because we covered this subject in high school. We all know what energy is. We know what work is. We know what mass is. So we don't need to go back to that. Now we can just use it. But when you go and check the sources, all these words are abstract concepts, and we ended up moving concepts. That's the physics of today, the official physics. And, you know, in this sense, I'm proposing a new physics, saying that we have to go back to basics, we have to go back to kindergarten, wipe the board clean, and begin with objects. I can move a dog, I can move a cat, I can move a rock, I can move a tree. I cannot move love, I cannot move justice, I cannot move energy, I cannot move information. So when people talk with these words, they are reifying concepts. And that's where I think physics has lost its way. Well, getting back to that other question, there is a language of physics, and based on objects, if objects are the bread and butter of physics, then the language of physics is a language of images. I should be able to explain, a person who is deaf, dumb, and blind should be able to explain a theory to you without speaking a word. He should be able to show you through a movie or through actions how this universe works. The language of physics is illustration. That is the language of physics. We can do it with objects. We can't do it with mathematics. Mathematics models certain descriptions, and that's as far as it goes. It doesn't. Mathematics cannot explain, and that's what science does, let alone physics. You must explain how, you know, a pen falls to the floor. What is the mechanism? You have to explain how a magnet attracts another one. What is the physical mechanism? To describe and say, yeah, they come together, well, yeah, we know that. And to put numbers to that, it's just another description, just higher level description. It doesn't do anything, it doesn't give us any further understanding as what the mechanism is that Mother Nature uses to bring these two pieces of metal together. So again, I think the language of physics, illustration. You illustrate on the board, you have a physical theory. If you can't illustrate on the board, you don't have it. What are you going to put, an equation?
That's right.